All right, last but not least, we're going to have radicals. So it's another type of function. So we've introduced rationals, which have denominators, absolute values, which we've kind of seen before, and radicals, which we've done with but haven't really graphed them. So, with radicals, it's different than rationals. Rationals, you can't divide by zero, but with radicals, you can't, we're not going to be able to graph imaginary numbers. So inside the radical cannot be negative because that would result in an imaginary number which you can't graph. So we have to assume that inside the radical has got to be positive, or I would even say zero is fine, because the square root of zero, if you got zero here, the square root of zero is zero. It's not imaginary, it's okay. So that's going to lead to a certain domain restriction. So if you think about what can I plug in for x, that's your domain. Remember, domain is the x values. So what kinds of numbers could I plug in for x, right? So if we just think about it, right? Could I plug in a billion? Sure, because a billion minus 2, it doesn't matter. It doesn't have to be a perfect square root. It just has to be positive. So that's fine, right? But if I plugged in 0 for x, well, 0 minus 2 would be negative 2. So that's I can't do that, because then when I get negative 2, I can't get a negative under a radical, because then it's an imaginary number. So if you're thinking, well, what if I plugged in 2, right? I could say x minus 2 equals 0, and that's going to be where it starts. So if you add 2, you're going to get x equals 2. And all of a sudden, that's okay. Unlike the denominator ones, 2 is okay. Because if I plug in 2 here, 2 minus 2 is 0. And so I get the square root of 0, which is just 0. That's fine. It's not imaginary. So I can start with 2. And then if you can see, yeah, of course, anything bigger than 2 is fine. 3 minus 2 is positive. 4 minus 2 is positive. 5 minus 2 is positive. 6 minus 2 is positive. Anything 2 or bigger works, but as soon as I pick a number less than 2, right, 1 minus 2, that's negative. I can't do it. Even 1.999 minus 2 is still negative. I can't do it. So starting with 2 and anything bigger than 2 is okay. So my domain, the lowest value that I can plug in is 2, and then the biggest value I could plug in, well, infinity, right? I could plug in anything that's huge because it still leads to a positive under the radical, right? So that's my domain. And then the range, right, you don't see a plus and a minus in front of that radical. So we're just assuming that it's positive. So again, it's kind of like just a rule with radicals. It's impossible to get a negative radical out unless you have a plus and minus in front, which we don't. So we just assume it's positive. So the lowest it's ever going to be is 0, and the highest it could be is technically infinity. The square root of infinity, I guess, but it's still infinity. So that's going to be the range. That's kind of a rule for radicals. If you just want to know that rule, it's not a bad one, but it's good to think about the math behind it. And if I graph this, it should confirm my 2 answers that I figured out algebraically. So you can see this is my graph, right? So, the domain starts at 2 and goes to infinity, right? From left to right, the furthest left is at an x value of 2, and all of these other x values are somewhere in the graph. So it's 2 to infinity. That confirms this answer. The range, right? Range is from low to high, y values. So the lowest y value, nothing here, nothing here, nothing here, and then boom, right? At y equals 0, that's where my graph starts. And then it does go to infinity. Well, Mr. Jocelyn, it goes up to 2. This arrow this will continue upwards to infinity. It takes a while to get there because it's a square root, but technically it will go to infinity. If you put an arrow on this, it does go up to infinity. So those just confirm my answers, but that's how you want to think about radicals. So once you get your notes done, guys, go ahead and start the homework. Good luck with it. I'll answer any questions you got tomorrow.